So I've got a question here. I'm trying to calculate the volume and the uncertainty in a 1p coin. I want the answer in meters cubed. So you can see that some measurements have been taken here. 25 coins were stacked on top of each other and found to be 4.2 centimeters high. This is a measurement because we have to line up the bottom of the ruler, or the zero of the ruler, and read off the 4.2. So therefore we've got a judgment to make at both ends of our reading, and the uncertainty therefore is the resolution, or 0.1 centimeters. The same is true for the diameter. You should always use set squares to measure diameters. They're a really good way in the exam of making sure how you're ensuring that things are perpendicular, or you're measuring vertical heights, and the uncertainty there is 0.1. Now to calculate the volume, I suggest you use pi d squared over 4. You make less mistakes. Substitute the numbers in here. So I've just written the 12.1, and then I've put the SI multiplier down to the minus 2 there, and I've divided by 6 to get the diameter of 1. I've squared it, and I've done the same here for the height. I've just written the number down, the SI multiplier, and divided by 25, and I've got the volume here. Now I've left this as a full value because I may well use this number later on in the calculation. But I've got to look at how many significant figures I should put this to. I've got to look at what numbers this is calculated from. It's calculated from 4.2 and 12.1. Some constants, but we ignore them. So this is 2 and this is 3. We always look for the lowest number of significant figures. So the lowest number of significant figures out 2 and 3 is 2. So I'm going to write my answer to 2 significant figures. So, getting ahead of myself, 5.4 multiplied by 10 to the minus 7 meters cubed. I now need to work out, I'm just going to write actually 2SF there so I remember that that is written to 2SF and not the full value. We now need to work out the percentage uncertainty. So the percentage uncertainty in the diameter is the uncertainty. Uncertainty divided by the value multiplied by 100%. So the uncertainty, well, if I look at the diameter, the uncertainty in 6 coins is 1 millimeter. So that uncertainty is spread across all 6 coins. So the uncertainty in 1 is equal to 0.1 centimeters divided by 6. And the mean value for the diameter of 1 coin is 12.1 divided by 6 multiplied by 100%. This raises an important point here because you can see that the 6 on the top and bottom cancel. So the percentage uncertainty in 6 coins is the same as the percentage uncertainty in 1 coin. This is why we read across many values, because however many coins we read across, our absolute uncertainty will always be 0.1 centimeters. The more coins we measure across, the lower the percentage uncertainty. So if I measured across 12 coins, that would be about 24.2, and therefore the percentage uncertainty would be half. So in the exam, the reason we measure across multiple numbers is to reduce the percentage uncertainty. So I work out what this is, and I get 0.826%. I'm leaving the full value there, because I'll need that in a calculation in a moment. The percentage uncertainty in the height, again, is the uncertainty divided by the value multiplied by 100%. Now, I'm not going to do the dividing by 25 here. I'm just going to plug the numbers straight in. So I've got 0.1 divided by the reading, 4.2 multiplied by 100% is equal to 2.381%. Okay. I now need to look at how I calculate the percentage uncertainty in the volume. Well, what I'm going to do is I'm going to take this equation here and I'm going to bring it down here. So percentage uncertainty in volume. Well, what am I doing to the diameter? I'm raising it to the power of 2. Whenever we raise it, we multiply the percentage uncertainty by the power we raise it to. That applies to square roots as well. In this case it's squared, so I'm going to double the percentage uncertainty in the diameter. And then what we're doing with the height, we're multiplying these two quantities together, and therefore we're going to add the percentage uncertainty in the height. So substitute the numbers in, is 2 times 0.826% plus 2.381% gives us a value of 4.033%. I've used the unrounded values here as this is an ongoing calculation. Now the question here asks for the uncertainty and the volume of a 1p coin. Now whenever it says uncertainty, assume that means absolute uncertainty. So we've got our volume here, 5.4 times 10 to the minus 7, and I've got my uncertainty here. So in essence, what we're working out is what is 4% of 5.4 times 10 to the minus 7. So the uncertainty in the volume is equal to 4.033 divided by 100 multiplied by 5.366 multiplied by 10 to the minus 7. I'm using the unrounded value here because this is a calculation, and I work out what that gives me, and that gives me 2.1641 times 10 to the minus 8 meters cubed. Now, depending on how the question's asked, if it asks the two things separately, you can write that and you can write that. It may well ask you, however, for the two combined, what is the value and the uncertainty in it, and we need to make sure these are the same number of decimal places. So probably the easiest thing to do is to put this, because we've got different powers here, is to put them to the same power. So I can go 0.21641 multiplied by 10 to the minus 7 meters cubed. So the volume is equal to 5.4. Now we need to make this the same number of decimal places as this. So this number here is 1 decimal place. Remember, that is because it's two significant figures going all the way back to the 4.2 here. So this is 1 decimal place, so we need to make sure uncertainty is 1 decimal place. We round this, so it's plus or minus 0.2. Put some brackets around that to make it nice and clear, times 10 to the minus 7 meters cubed. And that is our final answer there.